Hey everyone, this is a demo on a multi-modal security chat application. This system combines real-time chat with continuous biometric authentication using keystrokes, mouse behavior, and voice verifications. Additionally, it also integrates intrusion detection system to prevent spam and malicious activities in the group chats. So traditionally, like chat applications only authenticate users at login time, but if someone else get access after the login, the system cannot detect it. So this project solves that by continuously verifying user identity in real time. The system has two major modules. One is the biometric chat backend. Other is intrusion detection system. The backend is built using FastAPI and it uses BioLST models to analyze user behavior. Let me just log in a user. So I logged in. Sorry. So I logged in. So we have two things. So these are the direct chats, and we have a group chat in here. So in the direct chat, we have the continuous authentication feature, and in the group chat, we have the IDS feature. So in the direct chat, if I go to this user, just log in as this user also. Yeah, so as we have the real-time chat application, we're using WebSockets to deliver the messages. You can see the user one is on in, others are offline. If I message him this, the chat is open like this. See, it's delivered, and when the user will open the message, it will be read. Now, as I type, the system collects the data, like the keystroke dynamics, like typing speed and the timing. And as I move the mouse, it also collects the mouse movement patterns, like the velocity and the direction of the mouse, and it's collecting the data. So it's still showing the collecting data because the we haven't have enough data for that particular user to train the model. So that's why. But for user two, we have enough data, we have a trained model. So if when it has the correct data, it will show you the typing verified, like confidence in the score. And we have a three strike system. So if I start, like if I like, it's checking the mouse movements currently. So if I uh, move the mouse in a different way, like the other user, or if I start typing, say, it will detect and it will start the strikes. Like we have a three strike system. It's type slow so that it will detect and it will log me out. I'm just typing in. Yeah. So we have a three strike system. Whenever like the behavior changes, it will collecting and predicting the data every 5 seconds on the based on the batches. So it will log the user out the if the pattern doesn't match. So so in the chat application also, we are using by LST models. Means we are also using two different LST models. One is the keystroke model, one is the mouse movements model, and the system uses a weighted fusion model. Let me just show you. So we have a weighted fusion model. So we have given 70% weight to keystroke model and 30% to the mouse model, and then we fuse the scores of both the models and have a final score on which we check if the behavior matches the trained model or not. So if the behavior matches, uh, the session continues. Like user can normally use continue the session. They can chat. But if the behavior doesn't matches and we have a three consecutive mismatches, the user is automatically locked out. Like I showed. And same goes for voice messages. So at the time, like if I'm a new user, at the time of enrollment, we collect the user data. So initially, like the system enrolls voice samples. After that, it verifies identity using speaker embeddings. So generally, we collect the voice features, we generate the embeddings on using that. Then we create a centroid value of the embeddings. And after the enrollment phase is passed, then we start verification. And uh, so based on the centroid value, we do the similarity, uh, cosine similarity score. And if the it doesn't matches, we log that user out. So this is how the chat backend works. And then we have a adaptive learning feature. So the models are adaptive. They retrain automatically as more user data is collected. So accuracy improves over time because like we don't need to manually retrain all the models. Let me just show you the adaptive retraining pipeline. So we have, in this pipeline, we are continuously checking the keystrokes and the mouse events data in the database. So when we have, like for a new user, when we have 1,000 events for both, we train the individual models for that particular user. That also runs in the background, so it doesn't affect the backend. And when the training is completed, it saves the models with the user ID, all the scalar and the config file, and archive the old models and log the metrics and clears the in-memory authenticators. Like we generally load the LSTM models for each user in the memory, and when a new model is trained, it will remove that from the memory and load the latest model. So this is how adaptive learning is working. Then we have the group ideas feature. So in the groups, let me say it as user two. So in the group chats, we use a hybrid intrusion detection system. So we are using two models. One is random forest and the isolation forest. We are combining both the models to detect spams or attacks. So if there is suspicious behavior is detected, then the message is blocked and the user is temporarily banned. So let me show you how it works. So let's say for user two, yeah, if I start typing the same message like this, so we have a 10-second window. It will collect the data and start the prediction based on that. And we see the messages here. If I type the next message, it will detect and block the user. It will also, for the other users, it will remove the messages. So like messages are hidden, like by the IDS, and the user is blocked for the 5 minutes like this, and he'll be blocked for all the messages. Like he can't directly chat with any user till the period. Also, in the we have a dashboard. So this dashboard shows real-time attack detection and the metrics and the system performances. So as I just got blocked for the user because we have exceed the 0.75 combined score. We got 0.86. That's why the user was blocked. So in this, we can see the real-time insights of the IDS. So and let me show you the analysis page. So we have this pass rate, and in the analysis, we have ROC curve, precision recall curve, and fusion metrics and model performances. So you can see the ROC curves and precision recall curve. And these are the top SAP features like repetition score, as I showed earlier. So we have the messages. I'm continuously repeating the same message. So we have the repetition score. That's why the users are getting blocked. And you can also see the top attacking users. These these are the users which are attacking the most. So the system ensures a continuous authentication plus the real-time threat detection, making chat applications significantly more secure. Thank you.